from something like this to something like this. Its inventor, Zach Manchester, is here in the room. Zach, please stand up. Thank you. Zach is one of the members of our team. The one I'm holding is the first version with limited functionality, and there will be many more iterations to come. This is the star chip, a gram-scale wafer containing cameras, photon thrusters, power supply, and navigation and communication equipment. It's about the size of a large postage stamp, only a little bit thicker. This is the Silicon Valley approach to space flight, a fully functional space probe that can be held with 2 fingers and mass-produced at the cost of an iPhone. Our second breakthrough is the progress in nanotechnology, which is producing ever thinner and lighter metamaterials. This holds the promise of lightsails a few meters wide, weighing just a few grams. Together, the star chip and the light sail give us an ultra-light, ultra-compact spacecraft. We call it the Nanocraft. This is the light sail, and this is the star chip, our Nanocraft, our interstellar sailboat. Now, so much for the sailboat. And what about the wind? Well, the third major development is in photonics, the technology of light. If I pointed this laser at a nanocraft in space, the light would actually push it. Not super fast. If I did it for a full day, it would push the nanocraft to about speed of an ant. But the advances in photonics had led the development of phased light beams, many small lasers forming one powerful beam. Philip Lubin, who is also with us today. Philip, can you please stand up? Philip has been thinking deeply for the last few years about how to use these latest developments to drive light sails, and we're also delighted to have him on our team. As lasers get cheaper and more powerful, in line with the Moore's law, the beam could potentially be scaled to something like 100 gigawatt level. In principle, the system should work like this. So this was the array. This is the mothership releasing the sail. This is again the beamer on the ground. This is the laser beam hitting the spaceship. The mothership releases the spaceship again. Another light beam pushes it second time. And of course, the idea is to have multiple redundancy and to send hundreds and maybe thousands of them to one target. Over a few minutes, this nanocraft accelerates to about 20% of the light speed. This is 100 million kilometers an hour, rather miles an hour. This is 1,000 times faster than the fastest spacecraft today, or 1,000,000 times faster than a car on a highway. At that speed, it would fly by Alpha Centauri about 20 years after launch. It could capture images of possible planets, other scientific data, and send them back home in a beam of light.